Hi, maybe we can start now. I guess today what we'll be doing, we'll be trying to work out week 7 material and also some of the week 8, some of the macro. So you can see the slides, not a lot. So in this week 7, we have 2 main ideas. As you will see, the first part will be about network effect, about platforms, and the second part will be about cryptocurrency. We'll study a model of Bitcoin. And then if we have time, I guess we'll talk about some basic macro, which I guess many of you would have know it, so shouldn't be a big issue here. So, I guess let's get start. Okay. So as we said, we study about information technology, and the first thing is about platforms, which is different from the vertical or physical market where people meet physically. But because of the information technology that we break the geographical constraint. And probably many of you would know these days, whether it's Hong Kong or mainland China, many places in the world, that the brick and mortar market actually is not working very well because of the online is actually beating the offline. In particular, you will see one of the main things different from classical market is what we call the network effects. By network effects, it means that it's different from the classical thing you learn in microeconomics, where we have increasing return scale. Right? When classical way, why we have to assume decreasing return scale is that we should able to see that many firms in the market. Right? If there's increasing the scale, then one firm would be so efficient enough as he expand his scale production that will lead to monopoly, okay? And that is standard thing you would see when you have public utility, right? Power company, they will have these features, okay? And we will look at the platform, which because of the network effect or the money power, that means that big data will be an important thing. And we'll study Bitcoin. I'll study in terms of model, study why Bitcoin or how Bitcoin will work, and try to understand the economics of Bitcoin. Okay? So that will be the goal of today, right? But I mean, as you see, this will be fitting one of the case study that you'll be doing, right? To study Bitcoin. So, platform, okay? Why platform exists is mainly due to network effects. By network effect, it's actually continue what we studied last time about externality, okay? In particular, this is usually what we call the positive externality. The reason is mainly is because why you want to choose a particular product is because of other people, right? You can imagine that why people would choose WhatsApp in Hong Kong, right? In China, people choose WeChat. and Taiwan people just lying, right? It's not because of their particular features that in one, not in the other, but rather it's because your friend is using it, then use it, right? That Facebook or Twitter, right? It's very difficult to challenge them, right? When your platform feature this kind of externality, then you will see it's very difficult to change it, right? Probably many of you would notice, right? The platform that is also the big thing is like in China is Taobao, right? Or Tmall, right? And you note there's large externality effect, right? Because of you go there and why? Because there are a lot of goods to choose from, right? And because of the large customer base and there are many producers there, right? They are going to be mutually reinforce each other, right? But the problem of the Tmall or e-commerce platform is that different from the Facebook thing. Is like you use it is not because of other customers using it, right? It's because of many producers are also selling there. So that's why the network effect is not that strong in that sense. That's why Pinduoduo, right? And then they come in and they just can challenge Tmall very easily, right? It depends on the nature, but that's why usually in the literature they differentiate the direct and the indirect, right? For direct, it's like the Facebook, right? It's like because of use it, they use it. Indirect is like what we said is like because the other side of the market, right? It's like consumer go there is not because of the consumer, but because of the many sellers there, okay? But and let's look at the case we're talking about Facebook, right? The Facebook or WhatsApp or those platforms, okay? It's because of how likely we use it or the payoff using it, because it depends on how many other people are using it, right? Like in old days, right, whether you want to have a fax machine is because of the other guy have fax machine, right? Same as social network, right? You go to that place because other people using it, right? That's why Google Plus is not going to fly because not enough people using it. And if there's no one, you're not going to pay for it, right? So that is the main thing there. And the other, as I said, is like because you use it because of there are many variety to be provided in the other side, there are many sellers, right? The platform going to attract different type of people, then you interact. Usually you would people see they call the two-sided platform, okay? Because of many people using Windows, because of the lot of software there, right? And why there are so many software developed? Because there are many users there. So they are mutually reinforce each other. That is what it means, okay? And in terms of analysis, they're very similar. Of course, there are many intricate things, but the network effect simply means that, right? It's just like the system, the more the better. There's something increasing return scale. That is something we want to model. Okay. And we want to look at the most classical paper in the 1970s. This is a model for a telephone company. Okay. At that time, right, having a telephone would be expensive. Right? So that's why they tried to model that. Okay. This model will be there's some math, but I try to make sure that it's not too complicated. It's not complicated math. Later you see there's a graph and again can get what we want. Okay, it's not complicated. So let's go one by one. Try to make sure that although there's math, that don't make you scared. Okay. So this is the payoff if you buy the service, buy the telephone. Okay. It's concept two part. First part is the benefit of using a telephone service, okay? It's composed of two parts, right? The first part is BI, okay? BI is a uniform to 0 to 1, right? Some people don't care about how many people there will be 0. They care a lot will be 1. It's normalization from 0 to 1, uniform, right? And NE is how many people were there. Okay, you use the telephone service expecting how many people are there, right? How many of your friends are there, right? And this is the first part, right? The benefit of using. And the cost of using is minus P, right? The higher the price, the less happy you are. Okay, just very simple. That's two parts, right? The first part is how many benefits derive from interaction, right? It depends on how people are using, okay? And you take care of the price you pay, right? So that is a very simple model, right? It's nothing deep there. The only thing you can see here is slightly different is consumer heterogeneous, right? Some people care a lot and some people don't, okay? There's some slight heterogeneity there, okay? And so it's similar to the ideas, what we call vertical differentiation, right? So some rich people, they care about the product quality, that some people they don't, right? But the difference in this aspect is the quality, which represented by how many people are there is endogenous, okay? So that's slightly different from the classical model if you look at the vertical differentiation model, right? Firm would provide different type of good, high quality, low quality, right? But now it's not the choice of the firm. It's whether the product is high quality, low quality, depends on how many people in the network, right? If a lot of people buy the telephone, then the product is high quality, otherwise low quality, okay? And directly you can see there's a coordination game there, right? If a lot of people, the value of the product is very high. If very few people, the value is very low. Okay. So now, what happened is, now we look at this expression. Looks pretty crazy if you first seeing it, okay? But that is nothing deep here, okay? It just say that if the price is this, how many consumer would actually come, okay? And we assume that every consumer would have a expectation how many people would join, which is NE. So NE is exogenous, so consumer would expect, okay, 1 million people would use the telephone, that is expectation, which we will explain how this expectation comes from, but every consumer would have a homogeneous or the same expectation, how many people would join, okay? In that case, everyone will be able to tell whether he will join, right? If this is positive, they will join. If not, they will not join, right? For example, suppose NE is, okay, people expect 10 people will join, right? And suppose the price is like, I don't know, 5, right? What does that mean? If your BI, which is how you think you value the network, if your BI is 0.5, then you are indifferent, right? If your BI is more than 0.5, then you will join. Less than 0.5, we do not, right? So that's why I write the integration thing, just add up everyone, or summation as you like, that is above, right? And then that means that how many people would join would be this one, okay? Because you would just rewrite who would join, just look at BI is bigger than NE over, sorry, P over NE, right? You will write this inequality, right? And BI is uniform, okay? So will be 1 minus. The idea is like this, okay? Let me write that down here, okay? It will be BI, right? Will be uniform from 0 to 1, right? And this is 1 there, right? Right, this is the PDF, right? The probability density function, right? And who would join, right? Look at if the value is more than this, and I would join. right? My BI is more than this, I would join, right? Because you multiply minus, it means this is positive, right? So that means that I look at the value here, which is P over NE, right? And these people will join, right? So the probability that more than this is just the area of the rectangle, right? The rectangle area is the base multiplied by height, right? The base would be 1 minus P over NE, right? This is 1 minus over PE. This is 1, right? The height is 1. The base is 1 minus this, so that's why how many people join? With 1 minus P over NE. Is that clear? So this is standard uniform distribution, right? I mean, I guess you learned it in undergrad, but many years ago, right? So I hope this would be fine. I mean, of course, doesn't really matter how I derive this. If you don't want to understand, it's okay. The formula I have there, you just trust me. This is the right formula. That's fine. Okay. Well, we're not asking you to derive, but try to tell you how this can be derived, right? I mean, if you don't like math, it's okay. We are not math class, but I have to explain how I arrived at rather than you trust me. But I try my best to. If you don't believe, you just take this one, right? Just saying that you can see, right? The price go up, then less people come in, right? We're not natural, right? And you expect more people, the NE is higher, also this will be more, right? Very natural, right? You don't like the math, just look at the consequences, it's fine, right? The higher the price, less people come in. You expect more people to come in, more people come in, right? It's self-fulfilling, right? More people come in, more people come in. Is that clear? Okay, I hope that would be clear. I mean, if you don't get the math, doesn't matter, right? We are not math class. Just try to give you the idea, okay? So why we would need this, okay, is this can derive the equilibrium. How? To derive the equilibrium, we will use the term, what we call in economics, we call rational expectation, okay? Rational expectation equilibrium. What does that mean? It means in equilibrium, what people expect should be same as what equilibrium arise. So the NE and this N, the same. Okay? Same, okay? So actually we did that in last class, right? What is the bid-ask spread, right? What's the bid price? What's the ask price, right? Ask price will be the people expectation of the value of stock given there's a buy there. Okay, the same thing. Okay. Okay, here, same. Okay. Now, if you make this N, right, and make N a subject, you get this formula. Okay, so you put this N here, you get this one. Right? Just NP is NE there, right? You just rewrite that, make the P the subject, right? This is all you get. Is that clear? So look at this equation here. NE become NP, this one, right? And you multiply NP on both sides. Or you take 1 minus NP, multiply NP, you get this one. Okay, since some of you are not have happy face, then I just write that. How should I do that? This is the formula here. The next step is I subtract N from both sides. Okay? N minus N is 0. Okay? And I have 0, 1 minus P over N minus N. Okay? Now I add P over N on both sides. Right? So that cancel out. So 1 minus N, P over N. Okay? And then I multiply N on both sides. They cancel out, give you this formula. Is that okay? Just primary school math, but I'm pretty sure that it will take a while for you to get this one. Might be, okay? To be honest, if you ask me if I'm not teaching, then probably I will forget as well. So no shame of not remembering. But anyway, I try to convince you that this is the formula here, okay? So probably you would say, okay, I don't care this formula. Okay, doesn't matter. I give you the graph that will be what we're using, okay? So if you don't like this math, doesn't matter. Is that okay? Okay, so if you don't like this is what we have, okay? So this is 1 here, okay? This is 1/2 here. This is 1/4 here, okay, in this model, okay? In this model, as you see, okay, the demand curve looks weird, right? Standard demand curve expect what? Is downward sloping, right? So that means that this part is something that we know very well, right? If the price is 0, right, the lowest point, then everyone would join, right? This point, everyone would agree that would be very natural, right? And but okay, one interesting part is like this. Even the price is 0, it can be here. Okay, look at the orange dot. Price is 0, no consumer. You may ask why? Why is it possible? It's possible is because people believe that no one would join, right? No one is going to that, even though 0 price is not going to get you anything, right? If people believe that no one is going to join the network, no matter what price you're charging, even the 0, it's not going to work, right? So as later you will see, this upward sloping is more like a what we call a self-fulfilling belief, right? If you believe that not many people there, then you end up in a bad equilibrium here, right? You can see for each single price, right, there are 2 possible demand, right? And it is same as you learn game theory when you learn coordination game, right? If people cannot coordinate, they end up here. They coordinate, they end up here, right? It's similar to the idea about the macro or the market, like the bubble or sunspot, right? Why look at the housing price in China, right? Why they cut into half many places, right? There's nothing happening in the macro, right? Maybe there is, but people believe that in the future is not as good as they would think, then they'll drop, right? If they think that the market is going to be booming, go up, right? So that's why some people would say stock market, right, has much higher volatility or variance, right, compared to the underlying economy because of the sunspot, right? It's because people think the future is good, go up. Future is bad, they go down, right? That's later you will see probably about Keynes, right? Is animal spirit and so on and so forth, right? Belief play important role, okay? So there's a demand given by what we have, right? Because of if the same price, if many people comes in, you can sustain, right? Even the price is same, okay? So the demand curve is go up and then go down, okay? There will be some business implication of this, but we'll talk about this later, okay? Let's see if I have that thing in my slide. If not, I mention it right now. Oh, later. So I'll talk about that implication later, okay? But bear in mind, you will see that it's very important to be on the blue side rather than the orange side, okay, when you have a platform economy, okay? And maybe I can mention it now, right? And that's why you will see that firm will spend a lot of money try to go to the other side, right? That's why you see a lot of platform, they try to burn money, right? Remember in the old days, maybe a few years ago, there's something, the big platform is the ride sharing, bike sharing, right? And basically they charge the price such that basically almost cannot even recover the cost. It's low the marginal cost. You may ask why, right? One possible reason is they want to build up what we call, later you see, critical mass, right? If you are in this region, usually this is called critical mass, right? Once you go there, then things fly, right? So that's why they need to burn money in order to be there, right? So you can see all the platform, when they start, they try to burn a lot of money. Reason, they want to go to the other side. Not on the orange side, but rather to the blue side, okay? So that is the intuition for that, okay? Is that okay? Is that clear? Okay, so even the simple math, even the simple model can tell you why network effect is important. Why firm, they want to burn money, right? Because once they pass through the threshold, then they can jump, okay? It's a different world, right? That is the bad world, this is a good world. They want to burn the money to go to the good world, okay? So now, let us consider the model, because we don't have equilibrium yet. We just point about what equilibrium there. We consider a case where the marginal cost is less than 1/4. Why? Because if more than 1/4, no, the firm would just get out, right? Because the maximum to pay is 1/4, right? So we focus on a case where the price is between 0 and 1/4, okay? And in this model, we have mentioned that there are actually the 3 possible equilibrium. The first one is 0 demand, 0. The other one, the other 2 will be a low demand or high demand, okay? And one interesting thing is, if you are on the low demand, it's unstable. Let me go to this one, okay? So there would be 3 possible cases. Okay, this is low demand. Okay, this is high demand. This is 0 demand. Okay. And the question that later you ask is, first is, as we argue that this is already the outcome that is always there, you can easily get out there, you can easily get out from that one. And we argue that this is stable. These two are stable equilibrium. And this is unstable. Okay. By stable, it means that suppose we're in equilibrium, okay, suppose we're here. By stable means suppose we're here. Okay? Suppose someone suddenly gets out from the platform. Okay? Some people get out of the platform. Okay? And you'll be, suppose someone get out is here. Okay? And by stable, okay, it means that, okay, they would go back. Okay? If they go to here, okay, they would go back. Okay? So that is what we mean by stable. Okay? Why it goes back? Okay? It's someone left there. Okay? What would be outcome would be, right? And for this one, right, if and relatively for this one, if people left there, you will spill out, okay? So this is what we mean by unstable. The reason is being that if you look at this one easier first, is if someone comes in, okay, this, when you move to here, okay, say move to here, right, move to this one, some people comes in at the same price, okay, and people would think, okay, at the current price, it is the network effect is a lot, okay, so more people come in, okay. If you go down, you go to this equilibrium, okay. For this one, if some people will come in, okay, and the equilibrium adjustment will go back, okay. So that would be the, what does that mean here, okay? This means that this is what we call, in terms of economics, this is called critical mass. Right? That means that if you are able to burn the money, pass through this threshold, the market will self-sustain in the way that you get to the good equilibrium. Right? Because at here, you can calculate benefit is above the price, so people will keep coming in. Suppose some people come in. Okay? But if in this case you lost some people, then people think the current price is way lower than this, they will jump to this one. Okay? I don't want to go into the math, but that's how people call this critical mass. Okay? So that's why they will try to burn money to achieve this outcome. Okay? And there's a math which I don't want to go into detail here, okay? But I want to point out that what firm can do, okay, to make sure that they can get to good equilibrium. That is what we call insulating tariff, okay? The idea is that turn out to be the price should be increasing in the network size, okay? Suppose you do this, the price instead of a line there, your price is increasing in the network size. In that case, you would only end up in good equilibrium there, okay? So that explains why platform, right, by sharing, they charge almost very low price, almost free, when they introduce their product, right? And when the market saturated, they can increase the price up and up, okay? And for those who might know the ride-sharing competition, not in Hong Kong, but in China or in Singapore, which I was there, at that time, there's a many competitor there, and the price is so low that almost you get free ride. Okay, almost like $5 to $6 you can get a ride for a very long distance. The reason why, because everyone have very low market share compared to the existing taxi. Okay, so they want to build up the market customer base, and as more people using it, they reduce their coupon or discount, right? Getting more and more expensive. Okay? And you can easily see these days, look at the Tmall or Taobao, right? Now they give a lot of discount, right? Before they don't. Why? Because the market is shrinking, right? When the market shrinks, they will just cut, okay? And they cut way more than what we think, right? Because of the demand feature like this, okay? So what does that mean to investment? What do you mean by investment, okay? So since we're talking about investment class, right? So you are the finance manager, right? Investment manager. So use CAPM model. what does that mean to the beta? What is the beta? What's the beta if you compare a platform company to a non-platform company? Anyone try to guess? So what's beta? Go back one step backward. What's beta in the CAPM model? You took the investment class, right? So what's beta? Anyone want to try what's beta? What's beta? Anyone? No? What's beta in the CAPM model? So where that is, no one tried, then let me try, right? That is the beta CAPM model, right? It's looking at the return of stock, right? Excess return. And is look at it is the beta is the sensitivity to the market portfolio, market excess return, right? The higher the beta, the more sensitive to the market portfolio, right? And we learn, if you learn the consumption CAPM model, right? Instead of the market portfolio, you use the macroeconomy, right? The consumption, right? And if you apply to this model, right, you will see that the platform company actually would be very sensitive to the market condition, right? It's way more than the standard offline stores, right? Because if they get good economy, they can expand huge, right? But they're much more sensitive, right? Because once they cut the price, then all the platform will fight for not to fall below the critical mass, right? If they fall below critical mass, then they would die easily, right? So they would be very crazy when the market economy is bad, right? So they would, in order to survive, they would cut the price whenever even the bottom line, make sure that they survive, right? So you expect the beta will be high or low? High, right? So it'll be high. So that will tell you, this model already tells you that you expect this to be higher than usual, right? So of course, we don't talk about this directly, but you can see this company would have high beta, right? And if you are able to see who is there, who is the company there, then you can go, right? They can go a lot, right? If you get wind, then they become a very fast, and that's why platform stock, right, usually was considered to be value stock or growth stock. You guys are expert, right? So you can tell, right? Will be, if you are here, value or growth? Who think it's value? Who thinks growth? Okay? If here, you think it's value or growth? Value, right? So you know, right? So although you guys are pretty quiet today, but I hope you know it, right? But that means that change a little bit, right? So I hope this can tell us a lot, right? Because once you get to here, it's very difficult to be challenged, right? Even some platform comes in, it becomes stable here, right? So that's why you can see a lot of investment implication there. Okay, and here in this model, I try to talk about indirect, direct effect with more than one firm. I don't want to go to detail because there's some math there. What I want to give you the model and tell you the result. I'm not going to give you the analysis because the math there. Okay, I'll just tell you the result. Okay, so this type of model is very common in economics. Okay, to model competition. It's hoteling line. Okay, is there's a line 0 to 1. Okay, and firm 1 will be here. Okay, and there will firm 2 will be here. Okay, so there are two firms. Both will be on the ends of the two lines. Okay, usually we use this kind of model to model horizontal differentiation. Okay. means that some people would like black color, some people orange color. Okay, it's not vertical differentiation, it's horizontal. Okay, okay. So then look at the consumer. Okay, here. Okay, take a particular consumer here. Okay, then if you go to firm 1 to buy the product, okay, he will get the product which gives him utility V, okay, the value of the product, okay, and P1 will be the price that's charged by firm 1, okay, and the distance he traveled, right, this X, he traveled the distance is T times X, right? You can imagine that is how costly he has to deviate from his ideal point, right? He wants to consume this, but he had to go to here, okay? Or he just have to drive to there, okay? So this line can be geographical or mental, okay? Mental means this firm sell red color, this firm sell blue color. He may like purple, so he go to the red one, suffer some cost, okay? He go to the blue one, suffer some cost, okay? And the last one is what distinguishes the network model is this B plus S1. So in the standard model, you don't have the B plus S1, it's standard, okay? But now we have B plus S1. Why? B is the network effect and times how many people actually using the firm 1, okay? So that is the model, okay? So by symmetry, if that guy go to firm 2, okay, he also get the payoff from the product, pay the price charged by P2, the distance he travel, right, because you travel in this way is 1 minus X, right, and times how many people using, okay? So this is the model, okay? So this is the model people will use in very standard, okay? This is usually we call hoteling model. It's a line model. Okay. Of course, you may not like the math, doesn't matter. I just tell you the conclusion, right? Because that would be the main thing that is important. Okay. The important is like the model is like, okay, both firms has marginal cost the same, okay? And first the firm set the price and consumer just go, okay? And you will see that the analysis is very different, depends on whether T and B relative magnitude, right? Remember, T is how people will suffer, deviate from his ideal point, right? How expensive is the travel cost, or how the market differentiate. Okay? Larger the T, you have to travel more, right? With higher cost. And if otherwise, it's called the strong network effect. Okay? So why we have these two cases? Because this will be different model. Okay? I don't want to go to detail. Okay? There's some solving some equilibrium there, right? Because people will go and then they set the price. The standard model there. And if okay, this is the outcome, I think that's important, right? That's the only thing that we care, right? In this kind of model, what the price they charge with the same, right? Is the marginal cost, right? And this is how market differentiate, right? Market differentiation, right? The market is more differentiated, right? You can charge higher price, right? But there's an extra point here, is minus B, network effect. What does that mean? If the network effect is very strong, then the price you charge is work against you. Okay? So in that case, actually B is work against the firm. You will see the profit is T minus B over 2. Right? The higher the network effect, right, is not working very well. Right? And that is the reason why sometimes firm try not to make the B as much as possible, right? Try to make sure that the network effect is reduced. Okay? Don't want to facilitate communication. Make sure there's something not too large, but this is when B is 0, everything go back to the standard model, right? So that is the model of wholesaling competition, but there is nothing new there, right? It just means that when the network effect is not very strong, okay? So the model behave as if like the old days. There's no difference, okay? But when we look at the case where B bigger than T, that is the thing we want to study, right? Where this is standard case, okay? But in the non-standard case, B bigger than T, the equilibrium will depend on how people think, okay? And in the literature, there will be two types of model. One is called belief threat surplus. The other is called the dominant firm, okay? And the first one is that the first type of belief is saying that whenever the firm has lowest price, everyone go there, okay? The second one is there's dominant firm. There's one firm. If the price is same, everyone go there. Okay? The default there's a standard thing there. Okay? So so in the case, okay, this is very interesting. Okay? In the case that is belief threat surplus, where people go to the lowest price, you will see that price equal to marginal cost. No one make any profit. Okay? So even though there's a very interesting, right? Because when the network effect is not very large, right, or 0, firm get positive profit, right? Because look at the before, right? Firm actually get some profit here when B is not very large, right? But when B is very large, okay, turn out to be if consumer are looking for deal or right, then end up in they cut the price so low, no one make any profit. Okay? So even though network effect, the market can be hyper competitive, right? If consumer always seek for best deal. Okay? So that is one thing here. I don't want to go to the detail, but that's what it means. And in the other case is if there is a firm that has a belief that everyone will go there, right? Suppose you want to buy stuff, you go to Taobao, say, suppose, right? If the price is similar, right, you go that one. And even though they're the same, right? If the consumer is indifferent to two, they will always go to the one that they think that's good, right? Maybe habit or historical reason, right? In that case, the result is very interesting. Okay, the one that is people used to go, right, will get the market. Okay, the other guy charging the marginal cost, but no one is not getting anyone, right? So you may ask, why we have this equilibrium? We see this in Hong Kong. Firm 1 is TVB. Firm 2 is ATV or whatever, right? So regardless of what, I mean, you just watch this particular TV channel, right? If you think they're the same, right? I mean, remember in one day when they compete so big is they talk about the Judge Bao, or Bao Qintian, right? Bao Dayan, right? And at that time, the two TV channels give us exactly the same thing, right? No matter which channel you choose, the same thing, right? And people will still choose TVB, right? And that's exactly what happened here, right? So you will see that the market actually favor one guy, right? And that's why you can see the firm would want to spend a lot of money to be a dominant firm, to be the firm that people favor, right? They spend huge amount of money to capture this particular market, to be the firm that liked by the one, right? So that's why you can see In the monopoly case, people spend a lot of money to build up the critical mass, right? When there's a competition, network effects there, they will spend a lot of money to be the firm that recognized by the consumer. They have brand recognition and they can get hold, right? It does mean what? It means that investing in platform company can be very risky, right? Either if you're lucky, you get this guy, right? Profit crazy, right? But you're lucky, you may get this guy, which go into the rubbish bin, right? Right? If the market evolve into the case where they can be crazy, right? Then they can't get any profit, right? Of course, we can get the traditional result if the market is enough segmented, right? The market is, people think that service provided by different platform is different enough, they can get some profit, right? So I hope this give the idea how platform arise, right? And why things works out and things doesn't work out, right? You can see that this apply to virtual banks, apply to virtual broker, online broker, right? Because in old days, right, banks only serve people in area, right? But now with virtual bank, they serve everyone, right? So network effects there, right? But of course, for bank, it's not very clear that the network effect is huge, right? Because you put the money in the bank, it's not because of the other guy, right? It's like the bank is the middle guy. It's not really the platform, but it still has some feature there, right? But anyway, I should stop because a little overrun. But after the break, we will talk about Bitcoin, okay? So we will talk to some model. In this model, we go slowly because I think this model will be important. We go to the classical model. Okay, but anyway, let's have a break of 15 minutes and then we come back. Wait a second. Yes.
清楚呢三個係點樣樣加減然之後
即係話你個 price 咧，最後就會寫成嗰啲計出嚟啦。個 price market price 係 marginal cost 加個 market 嘅 deflation。如果 market 嗰 deflation 即係講中文貨嚟先，先會買呢啲嘢。咁即係話個 market 即係嗰兩個 factor 去成。咁 D 嘅話就係嗰啲人嘅 value， 即係啲人 value 嗰啲咩講到，大家都係爭嘅，咁咪。數字咁就啲人 D 係覺得係咩先？啲人覺得係咩 D 啊？個 D 就係啲人覺得佢要買佢唔係咁中差少少嘅嘢，即係個 market 就變咗幾 percent。如果啲 consumer 好 promotion 嘅時候 ，D 好細咗；如果啲 consumer 好 care 嗰個 network effect 嘅 D 好大。得唔得 ？Sorry， 即係係其實對於呢個 class 嚟講咧，就係呢個係我唔明白就係unstable 嘅 depend 有咩？譬如如果呢個係嗰啲咩，就 next 例子。但係如果有啲人殺咗過嚟，突然間 D 有啲人嚟買啦，咁呢樣嘢呢個 platform 咪好正咯。睇價格咪有噴兜緊，有越嚟越多人嚟，咁咪會嚟到呢個嘢。即係呢個係會轉嚟呢度。如果有少少變化，即係譬如話突然間有啲人嚟咗，咁同一個 price 嗰陣時，咁咪有啲人覺得呢個咁正嘅，咪再過去，越多對咁咪嚟咗咯，揾到嚟咗咯。咁呢度係少咗條友之後咧，覺得哇咁貴嘅唔得啦，我都唔買啦，咁咪去咗咯。所以叫 critical mass。係啦，呢個 critical mass，即係呢一點就係話佢唔係好穩定。呢個點啊？應該係個呢邊，但係如果有啲人嚟，有啲人突然間唔知點解嚟咗，或者有啲人突然間走咗，咁咪會少咗咪翻嚟呢個點，或者佢嚟呢個點。
哦，其實佢係呢個程序嘅移動，
係啊，我其實唔係佢呢度咩？因為呢啲唔係呢啲唔係，即係有人嚟之後咪更多，因為只有呢3個型號嘅。你假設係 adjustment 即係有人嚟嗰陣時，咁咪喺度咁要假設個 price 唔掂係嘛？有人嚟，跟住咪有人嚟啊，直到呢個點。
之後冇人嘅話，
如果冇咁咪就一個人走咗，第二個人走，跟住就係咁走，咪走咪走到冇咗。
所以佢就係根據呢條線過嚟。
係啦。
好，唔該晒。
就好似兒童詞咁咪都係咪又要 N 嘅減名咧？知道呢個頭先你未就到呢個 model N 減名啊嘛 ？N 乘1減咩咪就係咁。N 係0嗰陣時，咁呢個咪0咯。N 係1就0，一 constant equation。即係呢個啫。如果你喺呢個學過 x 乘1減 x，y
哦，所以
0 1啊嘛，1乘呢個係1，呢個4啦。個彎係個彎線，拋物線嚟㗎嘛。即係總之係咁嘅。即係呢個點啊？呢個係咪？即係係。我就知道要係咯，咁呢個上即係中學中3、中4學過嘅，但係你唔接受嘅就係咁啦，就係咁嘅樣啦。你可以唔接受嘅，但係呢個就拋物線啦，所謂嘅。你咁特別。諗住代個數入去先知道。哦，你咪代0嗰陣時，嗱0乘1減0咪0啦，1乘1減1咁咪佢係0咯。你代2分1嗰陣時咪4分1，你代4分1嗰陣時幾多咧？即係總之慢慢變啦。係啊，你畫出嚟就得。咁其實唔需要好容易理解嘅，即係話其實佢係一個price 裏邊有好多個唔同兩個 n 嘅係嘛？即係如果你期待緊好多人嘅嗰陣時，或者期待冇咁多人，佢都係有兩個可能性。我想問咧，咁其實呢個即係 reject 可以表達求有結果咩？其實你唔可以講幾多嘅，因為佢都唔係你應該有寫低錄詞，因為佢唔係一個同一嚿嘢嚟嘅。我哋可以咁講，你可以咁講嘅，但係佢通常我哋咁叫嘅，因為你有純單唔係同一個嚟㗎。第一成嗰個因為佢呢個係價錢定係價錢，即係佢唔係佢個 network， 即係我用咗定係令到你想用。公司就拎曬所有。咁所以因為 company 係 company 嘅話，即係 company 即係已經改咗條路線一啲分出嚟。呢個係唔係就唔關嗰個，唔係關嗰個。係因為跟住個 price 又 equal to margin Gary Becker 嘅，所以你睇住就話呢個即係我嘅要睇 depend 呢個好似冇點講。咁其實即係如果係嗰個 course 好貴，但係你要開心，咁我都可以噏。但係就都因為已經係轉咗個啲分出嚟，唔係個我之前個 market income 而俾。冇錯，所以就咁樣試。係啊，冇錯。即係你咁越多人，呢個係即係你覺得好多人用，咁你咪繼續用咯。你講冇人用，係嘛？即係好似股票咁啫，大家覺得佢升咪升咯，係咪先？覺得跌咪跌咯，就係咁簡單。佢哋係中意一樣嘅。我想問，你可以問多啲其實。我想理解多啲呢個其實係咪可以問我呢一年呢個開始就係點樣嘅？唔係一直到2個月嘅，佢即係話講個 price 有2個 possible 嘅 consumer， 因為係最大覺得係點？如果覺得係升尾個位咧，我覺得係點？你覺得好多人用嘅呢個位咧，覺得冇人用嘅位。但係如果間 firm 你話燒錢係咪呢個？佢係呢度已經燒啦，一路燒啦，因為佢仲要燒到呢度，跟住佢自動唔到呢度。係即係佢如果係咁做，但係如果冇你唔燒呢個位咧，咁你即係一定玩完，即係因為一唔燒個位就唔夠嗰個唔夠數。咁但係如果個消費者個數冇乜利，即係佢越貴我就即係話而家冇乜人用咁平，我都唔想用啦。我都唔知點個嘢，我即係好似 Google Plus 咁樣，你都唔使我都唔用啦。係咯，冇人用，所以咪係咁燒錢咯，燒到嗰個位大家足夠人用啦，咁咪用。即係如果我冇競爭，我就燒多1蚊，我令佢啲嘢過少少，佢就會。係啊，佢會再上一再上入。即係如果冇競爭，所以正常嚟講，佢做嗰個 business 會咁啦，其實嗰個 price，即係話你少嗰陣時會好平，可能低過成本，呢個冇講成本，可能成本嗰個位，但係 cost 幾 low 嘅 cost 你開頭嗰陣時，直到嗰個位先至會賺，即係譬如講翻張 cost 咁你即係話喺之前點樣食咧，係咁蝕錢啊嘛，係咁蝕㗎嘛。 我都冇講個 cost， 你個 cost 點擺喺度一個 model， 即係話你可能係先人咁燒錢咯，一落係咁燒咯，一啲公司係咁燒就唔解釋，係咁燒。緊就係話你個 firm 嘅，如果你想正常嚟講 firm 嘅人咁做，你個 network 即係冇人嗰陣時咪好睇平咯。即使你變到個 cost 都會好貼緊晒。如果譬如話我 cost 喺度咁咪好貼緊，depend on 你個 cost 係咁樣點樣畫佢。而家個 price 喺度啊嘛，只要你個 cost 係 below 呢條線嘅，咁咪值緊錢。即係話如果你而家不同咁啊，個 equilibrium 喺度咧，optimal 就係咁你如果係你正常嚟講 expectation 嘅話，應該係正常嚟講係點樣 charge 啦，或者點樣都冇所謂一條線啦，係嘛？咁你就跟住個 charge 啦。咁如果你個 cost 個 marginal cost 係咁嘅，marginal cost 係咁，咁咪即係話呢度係咁蝕緊錢啦，咁咪燒錢燒到之後可以賺咯，喺度係咁燒咯，喺度係咁燒咁賺翻咯。咁通常你會睇個 cost 大，但係你之前係咁燒錢，所以解釋點解會狂燒咧，就係因為佢燒到之後燒呢個位，咁就可以霸到個 market。高咗個佔賺係咪？高個 M.Phil 又賺。咁因為呢個你個 price 你 charge 嗰啲 price 咯。
高個 marginal cost。高
咗個 marginal cost 開始賺錢啦。通常都係咁係咁燒㗎，點解我哋咁燒就因為你燒咗個位就發達啦嘛。但大家就狂燒啦，燒到等要燒咯。
咁我去翻呢個點唔值嘅事。
唔會試，你個點係高喺度㗎嘛，夠高㗎嘛。
但問題係我喺個 price 入面個方向，即係我可以話呢個係一個唔好嘅現象，即係 price 太低。咁你會做啲？如果 price 即係譬如話 price 10蚊，咁究竟係10蚊？咁咪10蚊嘅時候，啱啱話呢個係。咁人哋所上升個問題係佢大家係咪一齊係一個過咗升啲，好多人嚟你個 platform 都明，咁咪賺得錢，咁咪就得。就 Facebook 咁啫嘛，好多人嚟你有好多人嚟我哋 Facebook 知有機會。係啊，問題你都唔通嘅時候，如果做到 price 唔知佢。咁咪呢個 price 係 follow 呢條線啊？呢個就係個 price，呢條應該係你如果有咁多人嚟，咁你 charge 個 price 係不斷咁增加嘅。哦，咁就係頭先講嘅，就係話你所有 platform 都係咁咯。開頭嗰陣係咁燒咯，嗱，要燒緊錢啊嘛，係咁俾 discount 你噶嘛。你到之後一路俾到夠啦，咁咪開始加價啦。嗱，幾多貓都有啦，開頭都平到燒，即後嘅價。我想具體啲理解喎。increasing price。因為咁樣做咧就阻止咗你個 back 呢邊，你咁做就阻止 back 呢邊。佢呢邊哦。但係佢點樣嚟喺度？你自己定，你自己講個 price 個。佢喺度亂咁話俾你。即係佢係 theory。唔係，咁即係解釋啦，點解個 price 係咁樣樣？係。你 as long as 係咁就冇問題㗎啦。咁就唔會掂到呢個得咯，冇所謂。咁如果佢哋係改變，佢即係最大。你定個點？你定嗰啲唔係最大 profit 㗎嘛？最大 profit 係呢個，因為你 P 成 Q 啊嘛。呢個應該最 optimal 嘅點嚟。喂，咁即係去到呢個呢邊，你最大呢度㗎啦，係咪？任你揀，你係揀一個點啊？我記得啦，你最一定係點啊？中間點樣去冇所謂嘅，你只要避開呢一點啫喎。咁你一路咁平咩？咁你依家點啊？你啲人變翻係個個去個 price 咪係咁上啊？其實好理論。唔係呢個唔係呢個理論，呢個就係 exactly explain 點解 platform 開始會燒錢，一路咁燒。但係個問題，我燒完之後，我一定要個咁你冇人保證到咩嘅？即係話解釋嗰個 behaviour 點解會係開頭係咁燒錢，燒嘅錢嘅原因喺邊度？因為燒錢，你做乜咁癲咧？係咪？做乜基本上唔使錢咧？好似你踩單車唔使錢㗎嘛，好平，係基本上唔使錢㗎嘛。點解會咁樣燒就係因為大家都想燒到個位置。咁如果3、4個 market， 咁你值唔值嘅話，係啊，咁就燒㗎啫。咁大家如果燒咪燒到，因為你如果一輸就輸到底數都蝕埋㗎喎。咁就係咯。係咯，winner take all 啊嘛。所以你只能夠換一個咪，一大家係咁燒咯，燒到成為世界第一咯，係咪先？你唔燒世界第一嘅話就唔得㗎啦。一將功成萬骨枯咁先。所以講啫，呢個 imply 個 beta 好大，呢方面係 promise。我
可以 increase body differentiation 咁咪去翻，如果 increase body differentiation 咪去翻呢個咯，咁就呢個知呢樣嘢咯，大家相互係咯，即係拼多多嘅生意，淘寶做翻佢哋，大家分開翻，冇咁競爭。如果唔係京東咁嘅，佢都有自己 defensive， 京東有自己識做嘅，所以即係佢盡量 defensive， 如果唔係盡 defensive 少。如果大家都同一樣，大家都冇路嘅。所以如果清東馬譬如話踩單車就冇得唔燒啊嘛，因為大家都一樣，覺得好難去整之類嘅，冇得整。佢要點樣去 defense？ 嗰邊就係你買用個 product 有幾多？咩？嗰邊唔應該喎。即係有分別。即係對於你嚟同佢嚟講都係除非你話去香港做 V1 就相對 V2 啦，咁個基礎就有關係。
有升好似係嗰度佢用
升嚟嗰啲度。啲講 proof 咧，冇人 care 嘅。我哋想講 proof， 大家見到大家講呢個都大家都已經執緊，對呢個食呢個好難嘅，唔係主要個 demand 唔係正常㗎嘛。係啊，其實正常 demand 係咁㗎嘛。咁但係有呢個 version 就因為你會機會諗到嘅，有機會好同啲人㗎嘛。取決於你嗰個大家覺得有好多人對咁樣。係啊，呢個係一個好即係好現實世界嘅嘢。係啊，我覺得係。就係咁。你覺得係好多人對，好多人對，覺得冇人冇去咯。呢個 platform 嘅係啊，呢個未啊。所以我哋特首咪咁講啦，係咪唱好香港故事咪喺度咯，係嘛？咁有啲係咪啊？外國嘅勢力唱壞我哋咪喺度啦，係嘛？所以咪有個駁嘴隊啊！
我想問多一個問題咧，關於個 CCAP， 因為我之後睇過啲圖，美國 GDP 同埋 S&P 剔咗落翻出嚟，嗰個 CCAP 係幾多？跟住我睇翻中國佢過去由97到依家個 GDP 升咗20%，但係 MSCI China Index 升咗1.5%，咁就即係你除非話個 CCAP 個 beta 係0.00幾咁樣做到啦，但係如果唔係，其實你中國好難做 CCAP，
因為 CCAP 係最 market 咗啦。個 market 必須嘅 ，CCAP 就唔係派㗎啦，係咪先？主要個問題係你個 starting point 係咩？係呢嚿嘢啊嘛先。咁呢嚿點樣啊？個 market 一定要 market 必須就唔等於嘅，係嘛？
但係唔可以用到嗰個 lambda， 唔係嗰個係。
你 discount cash flow 嘛？你呢個就唔得㗎啦，冇呢就唔識。因為中國係咩啊？大家冇乜 investment channel 啊嘛，唔知咩意思啊？好似咁啦，喂，你知道呢樣嘢？你懂啦，你哋點樣？你呢個好多呢啲。
Okay, let's resume.
Oh, no people feel great. People feel terrible. Equal number of people terrible, good and okay. So only have 7 people write in, but at least it's okay. It's not too bad. Still okay. Not that bad. Yes. So as you can see, we saw one thing is the network effect makes firm profit is very sensitive, right? They spend a lot of money to build the critical mass, right? They'll burn money, and once they establish the critical mass, become the monopoly, then it's very difficult to challenge, right? So it means that if you consider Kaplan model, beta will be extremely large, right? Of course, before when the market is in the early stage, right? But when the market is at the later stage, the beta will be very small, much smaller, right? Because of no matter what you do, they will be very stable, right? Look at Facebook, right? Regardless of what they do, it just kept what they are, right? Google, right? No matter what stupid thing they do, right? They keep the market share. It's very difficult to challenge. Or Microsoft, right? No matter how play around with the Windows Office system, right? Although most people think they change for bad, but they still keep the market share, right? And become more like cash cow, right? In that sense. So I guess this explains some of the idea you learn in classical investment theory, right? Expected network can change a lot, right? And now we have so many network firms, then we'll see, right? Same as AI, right? AI is another related idea, right? AI is the thing that what makes AI so different is, again, increasing scale of economy, right? Because of once you have a AI system there, can replicate very low cost, right? Can make the cost of capital very low and can substitute labor. And this is also looks like a network model, right? Because if one firm is successful, everyone use it, it will become so profitable, right? That's why Tesla has so much premium, right? Because people think his AI or his car can easily scale, right? And Tesla, surprisingly, comparing to other car company, has a lot of strong network effect, right? And you drive Tesla, and you feel very happy, and you see other guy had Tesla, also very happy. I try to look at people in the US. I don't know people in Hong Kong whether you were happy if you see other Tesla car, but in the US, people would be very happy. There's a fan club of Tesla and so on and so forth, right? Because they like your neighborhood or your friend also doing Tesla. Okay, kind of very weird, but that happens. Okay, as you see, right? If you can't beat them, join them. More or less like this, right? Can we explain the math just a little bit instead of skipping all together? Okay, I will do that for the Bitcoin. I will go slowly for this one. Because I think that it's always trade-off, right? If I go over some math with detailed, I've sacrificed the other. Because time constraint, then I will just, I'll go over some math, okay? I mean, for Bitcoin, I go in very detail, step by step, okay? For some other math, if you're interested, can tell me. But otherwise, I just tell you the answer. Company annual review plus school presentation work are deadly combination. I guess our presentation is not a lot, I hope, right? Because this is the only assignment we give in this class, right? So if you still complain, it's very hard to give assignment already, right? So I hope you're still okay. And it's all group work, so I hope that is not too much trouble. And I hope still okay. I do understand. We are asking you to submit your presentation, your final report on the day that before you present. If you need some extension, we can talk to TA to see if we can extend your written report. But I have to ask TA, okay? But I hope that's okay. So let's go back to here. We'll go to the little bit, because some people said I need to go to the math, so this one I will go to the math because I think it's worth talking about the math here. Okay. What we talked today, Bitcoin, okay? We'll go to the model by Satoshi Nakamoto, right? We go to the original paper that created Bitcoin. Okay? The paper is Bitcoin peer-to-peer electronic cash system. Okay? So we'll go to the math in detail one by one because it's a classical paper, right? It's a shame that we don't go over in detail. Okay? Although we don't go over the computer science detail, we go to the math detail. Okay? We just assume that math exists, the computer science thing there. So if you read that paper, you will understand the economics, not the technical thing, but not the computer science thing, but the economics will be clear. So you look at the paper, what it said is why he invented Bitcoin. Or, of course, we don't know whether this guy exists or not, but before Bitcoin, actually there's a lot of electronic cash has been proposed, but they don't fly. Okay? The Bitcoin is the first cryptocurrency that actually works out. Okay? And what was the problem that cryptocurrency tried to solve? Probably many of you would know, but for the sake of simplicity, we just go one by one. The main thing is because of internet e-commerce, right? The two-party transact, right? The problem is in the real world, the transaction is on spot, right? I give the good, you give the money, right? I don't need another one to verify. The problem of the e-commerce is the two-person transacting is not the same spot, right? You have to send the good and the money, right, over some non-geographically, not the same time, right? So classical problem would be you would have a third party to verify the good has been sent and the money will pay, right? That's what you do when you go to the electronic e-commerce like Tmall or Taobao or other Amazon, right? Once you get there, right, you confirm, the money will pay the platform, pay the seller, right? The platform will be the one who verify, or your credit card, the credit card will be the one who verify the good is being allocated, right? There will be someone to validate the good has been delivered and money will be sent, right? Someone will be there. So what the Bitcoin trying to solve the problem is they want to do it without the middle guy, right? Because why? The middle guy may not be honest, may not trust it, or the middle guy may have problem. If the system crashes the middle guy, then that'll be issue. So that Bitcoin is basically try to do with the middle guy, okay? But doing without the middle guy runs into the problem with what we call double spending. Double spending means that when one buyer try to buy the thing from the seller, okay, say, okay, I want to buy this good, okay, and you send me the good, I send you the payment, right? But without the middle guy to verify, because money payment can be reversed, right? I mean, I can make sure that I just reverse the order of paying the money, right, and buy again. Right? If the computer is so efficient, fast enough to reverse the order, I can use the same money, spend twice. That's why they call double spending. Right? Because, right, if there's no third party to verify, the money in the e-wallet there, I can use the money to buy this and money to buy that. Right? Because before the settlement happened, I can use the same money to buy many times. Okay? So we have to figure out that how to solve this problem, and the paper try to use cryptography, which we don't go into detail, but there will be something, right, to try to use the cryptography, use computer system to solve this problem, and that's why it only appeared in 2008, right? Because since after that, the computer is fast enough to do this. Before that, we don't have enough fast computer system, right? And so the goal of the paper, if you read, is they want to have a payment system, okay, such that the probability of successful double spending can go to as low as possible. Okay, so that is the original paper. Okay? Nothing invented by me. You can read the paper. That's what they try to say, right? So is that clear what the model is, right? It's just like the payment system, okay? But without banks, credit card company, or platform to verify, okay? So we need to do that, okay? And probably many of you have here, there's a blockchain, right? And that is closely related to the Bitcoin, right? So let's define what blockchain is. Blockchain is basically a book, right? Record who had money. That is a blockchain, right? Later we'll see what's a blockchain, but it simply means that a list of the record, right? Who has the money and who pay what, keep going on there, okay? And they record who do what, right? And why they call block is because everything is concentrated in a single block, okay? And build up a block, right? There's a light brick there. Some transaction break combine into one block, and there's 10 transactions combined into one block. Just like Lego, right? That means several transactions combine into a single block, here and here, right? Just build up a chain, okay? And so initially, maybe I own $10, you own $20, you own $30. It's written down in the book there. And if I want to buy something, I pay you $10, say, and this transaction will record there. Okay, keep adding. Okay, in a way that no one can change it, immutable. Okay, so how to make sure that it's mutable? Is there some cryptography theory to support that? Okay, and the idea of blockchain is. The Bitcoin is like this block is the record of who pay what, right? Is everyone have the record? Okay, potentially everyone have a record, and the record is online and in every computer. Okay, and you can't really cheat. Okay, not easy. Okay, if you cheat, you have to make sure that everyone will agree, right? Because it's like majority rule. Okay, everyone the record. Okay. What is the right record? Is everyone agreed that is a record? That's a record, right? The idea is like the cash, right? Why this particular paper is a cash? Because everyone believes it's a cash, and government say this is a cash, right? This blockchain is saying, right? Everyone record who has what, okay? And everyone agree this is what, then this is the case, okay? So this is blockchain. And as we said, right, because this blockchain is the ledger or the book that everyone holds, right? The problem is everyone can add it, right? Everyone can add there, right? Everyone can manipulate it. Then how to make sure that it is not cheated, okay? Okay. In a Bitcoin, they would call proof of work, okay? And it's there's a computational puzzle, okay? You have to solve it before you can do it, okay? And if you learn there's some private key, public key there, right? Those kind of stuff, basically just like when you transact, use your wallet, right? There's some secret password, secret key, right? Private key, right? And can add with that password, can open your wallet, right? And can say, I pay this to that one, and this will give you some output, okay? And this output, right, give you something to solve, computer puzzle, okay? And the puzzle will say things will match, then you'll be there. You can imagine there's a block, okay? There's some lock there. Okay, everyone has a key in your pocket. Okay, you put the key there, open your box, that money there, you pay. Okay, and this payment have to be verified, right? Because you say you pay X amount to some guy. Okay, have to verify you have this amount of money, right? And they add to there. Okay, so that is in order to be add there, someone to do some calculation based on your key. Right, based on your result, the public key, and based on that, we do calculation. only the calculation is being done, will be fine. Okay? And you can easily imagine that how to solve is like guessing a very large prime number based on your private key, right? Based on private number, and add to the whole blockchain, right? Then come up with some computer puzzle you can guess. Okay. And you will see this is like a guessing game, right? Guess the prime number, very big prime number, right? And the prime number, what's the right number, depend on what the key you have and what the chain you have, right? And without knowing your key, it's very difficult to guess, right? So, but anyway, as long as this is what we call proof of work, it's a Bitcoin. Okay, I mean, you don't have to worry about the technical detail, but basically just like, in order to add there, people need superpower to compute, right? There's a miner, right? They're using a very, very fast computer to make sure your transaction is valid. Okay, so that's the thing. Okay, and since we said we need a computer to put your transaction there, right? So the question is, who will do that? Okay, and what we call this is we call mining. Okay, there are some people, okay, who will do this. Is the mining will solve two functions. One is the security. Okay? Security means no one would try to manipulate the blockchain. And the second one is the mining. The mining people would try to make sure that trade will be transacted, right? Because you're going to put there, you need to do computation. Okay? So miner is very important, serve two functions, right? To protect the system, right? And also facilitate trading. Okay? So in the Bitcoin, so the miner actually would earn two revenue, right? One is, okay, they would, okay, if they add things to the block, get accepted, they get money by the system. So if I buy something, okay, and someone try to add this thing into the block, okay, by successfully adding this, they get money. Reward for adding. That is called block reward. The other one is like, I want to buy something, I broadcast this, someone have to put it there, right? If I want my block to be added earlier, I need to pay the fee. Okay? So you can imagine this is just like the stamp duty or the fee that's charged by the stock market, right? I mean, you pay more, then go faster. Okay? This one is like adding the block there, you will get paid by the system. Okay? This is written in the system already. Bitcoin already decide this block reward. Okay? So it's inherent in the system. Okay. Now, the main thing of the Bitcoin is decentralized, so no one is going to own it, right? The blockchain, right, is the record who get what and who pay what. You can see it, right, from the very beginning, the inception of the Bitcoin, right? You know who get what, okay? And if you want to add something, right, you have money in the pocket and add and broadcast the transaction, and someone add there, miner, right, would add there, right? So that's how this one. And the important part here is everyone can enter. That's free entry. So that's fully decentralized. Okay, so that is different from the bank or NOC, right? Where bank don't have this thing, right? You can't. There's no free entry for the bank, right? No free entry for credit card, right? But this one, everyone can control it. Right? Everyone can get in and solve the block, right? So one of the problem of the Bitcoin is what we call fork. Okay, the reason why fork exists is because technology cannot instantaneous. Okay, so the idea is now suppose the chain, maybe I draw a graph there. Okay, So block means, okay, now first is something like starting point, right? Someone say X have, Mr. A have X dollar, Mr. B has Y dollar, right? And there's another block saying, okay, A buys things from B, right? So maybe A would be minus $1, and B would be plus $1, right? That's, you try to build these blocks up, right? So this is what we mean by blockchain, right? And in order to add there, right? In order to add this transaction, you need their account and calculate some mathematical puzzle. Once you solve it, you'll add there, and this broadcast to this whole system. And everyone look at this, okay, this is the right thing, then they will do it, right? That's a formula to show this is correct, okay, to check. And the problem is, right, it takes time for this to add there, right? And at the same time, there may be two transactions happen, right? At this point, maybe A pay B this, and of course, there may be something like A would get money from C, so on and so forth, right? The question is, who would enter the system is unclear, right? Is it possible that, okay, in some cases, red, and then blue, and then green, but someone may say, and then orange, right? And then in some other system, maybe red, green, and orange, okay? So the blue was not there, right? Because remember, blockchain is, you have to, once you solve it, you have to dispute the whole network, right? Everything on the same copy, right? Takes time, right? So it's possible that some people have this one, some people have that one, okay? And how to solve this problem? Coordination problem, right? So what they propose is what we call the longest chain rule. Who is longer with the one we use, okay? So if equally long, then go to the earlier, who is earlier. So there's a rule the Bitcoin would do, okay? But that it means what? It means that if you want to hack the system, right? If your computer is fast enough, okay, you can make money by cheating. Why? Now A is paying money to B in this block, right? So in this one, A is paying to B, right? So how A can cheat? A can cheat by looking at this one and try to create some new block there, right? Make it longer. Okay? Make it longer. Okay? He tried to process other transaction to make his chain longer, then he don't pay. Right? Because this block will say A is paying money to B. Right? A is by cheating, by doing the wrong thing by very quickly do this. Okay? And by doing this, he can say, okay, look at this thing, this is the new one. I actually don't spend any money. Okay? That's how the blockchain hacking into this one. Okay? The problem of Bitcoin is trying to avoid this problem happening. Okay? So that is the main thing of the Bitcoin. But I will talk about the math later, but that is the idea. Is there a question before I continue? Because some of you look puzzling, but I would be, because I guess this is something that you are expert, so you guys should know better than I do, right? Because Bitcoin is something very common already. But any question before I proceed? Is there a question? Is there a question? Because this is how the Bitcoin looks like, right? Because there's some money you have, add and subtract go there, and suppose this is the authentic transaction, should go on this way. How A would be cheating is try to use the computer very fast, make a longer chain, and pretend to be the one that's authentic one. So that's how. And the main problem is how to avoid this happening. That's the Bitcoin was doing. Is that clear? Yes.
So for the longest chain rule is that the minor should only add one to the longest chain.
Yes.
So that's the case that when I have 3 and the others have 1, then all the blocks should add to mine. So mine is getting longer and longer, and only mine is getting longer. So is there any other chance that the ones are getting like based on the longest chain rule, then there's no chance for other chains to be added?
Yeah, because you have to, okay, suppose you this, right? You build this chain and you broadcast to the whole system, and the system agree that's all right, then you're done. So only the very short period of time, this you can do. Right? You can say, I cannot say I reversed like transaction any years ago. No, I can't do it. Just short period of time before everyone accept this. If you're fast enough, right? You're fast enough, then you can avoid, right? Because like A try to buy things from B, right? A say A is like, I try to buy goods from B. Okay, I buy your thing, you can see the transaction there, and then give me the good. Once you give the good, I'm fast enough to do this, then I don't pay anything. So that is the idea. But of course, when everyone agree this is the longest chain, done, then you're done. You cannot say, okay, I go back to 1 million years ago, let's change it, but I have longer chain. No. Once everyone dispute, everyone agree this, that, and done. Only when there's conflict arise at a very short period of time, then you have this problem. Okay? Any more question? But of course, I guess many of you would have know the blockchain idea already. Okay? So he looked at the original paper. We look at there are 3 types of model for the agents. One is called attacker, which are the one who are trying to cheat. Merchant is the one who sell the good. And the miner, he just try to earn money from doing mining. Okay? And the attacker is the cheater. He try to buy the good using the Bitcoin, and they try to reverse it. Okay? Not paying the thing. And double spending is like, I buy something, I cancel the block. That's why I just showed you, right? A try to buy something, pretend doing the transaction, and quickly he build the block to pretend not doing anything, right? So that is double spending. Okay. Now, all right, as we said, how to reverse payment, just create a new chain, okay? And new chain is know exactly the graph I have shown you, right? The blue one is gone. You create a new one, there's no blue, right? Exactly this one, okay? And everyone accept this because you're longer, right? And yes, formally just like you solve the puzzle, adding more block, and because do that, then you can reverse it, right? You see, right? Because before like this, but you're fast enough, you build a longer one that accept your payment. Okay? So how to avoid attack? Okay? It will show you, it's easy to see. If everyone can add the block there without cost, then no way to avoid it. Right? So everyone can add a block without cost, then you cannot solve it. Okay? So that's why he proposed, okay? It takes a complicated puzzle to add the block, right? Not everyone can add. You add it, have to pay some money, pay some cost to compute to do it. Okay? So that is the main thing there. Okay? The first thing, right? In order to add your transaction into the block, it's not costless. Have to use some computer to do it. Okay? The second point will be don't send the good immediately. Wait some time before you send the good. That's what the original paper is said. Okay? So, but we go to the math a little bit to see why. Okay. Let's go to formal model. I'll go very slowly. Don't worry, this model is more like a physics model, some probability model, not economics yet. Okay. So the setup is very simple. You can see it's very mechanical. Okay. First is every minor have computational power Cm, that's the number, 10, 20, 11, doesn't matter. Okay? And power attacker have some number Ca, that's it. Okay? And there's some exogenous constant pi, okay? Maybe how fast the computer system is, and then the minor, okay, using the computer, how fast they can generate a block will be follow a Poisson, right? Time t, right, will be his power times how long times the multiplier. Okay, why Poisson? Poisson because you're solving a problem. Sometimes you can solve it, sometimes you can't solve it. And to model this, it's easier to use the Poisson, right? Because Poisson has a nice feature of everything is independent, right? You learn probability theory, right? Poisson is the easiest thing to model, right? If you try to model discrete thing, right? Because binomial will be limited to 0 to n, right? Poisson, you don't have to worry about it, right? So if you remember that, right? Poisson is, and how many blocks you can create is independent when you start, right? It's proportional. Okay? And attacker is followed by Poisson. Okay? And now here is the merchant will wait, okay? When they send a good, have to wait Z number of block, right? Maybe Z is a natural number, be 1 or 2 or 3, right? So suppose you pay me the payment, and he will wait 3 more blocks to create before sending good. Okay? So this is how long you wait, okay, before you actually send the good out. Okay, this is the model. Okay, the notation, I hope this is okay. Okay. I guess Poisson is okay, right? Or you have question about Poisson? So now we have the model, okay? And on average, okay, after time t, okay, this will be number of the block that created by the miner, right? And this will be the block created by the attacker, okay? And this is the time that the merchant waits until they send the good, right? And the delta t is the difference between actually the attacker and the merchant. Why? Because the idea like this, okay? Starting this block, this is starting block, okay? And the merchant will start actually wait for t, right? We start 1, 2, 3, 4, da 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 da, and z, okay? And after that, then he will, after this block being built, he will send the good, okay? And then the miner, right, after t period, right, will actually build this M there. Okay? And let me the start is the transaction, right? Transaction. Okay? So And the very beginning is like here, right? There's a beginning point here, right? The transaction happen here, right? So if the attacker need to attack this block, what he do is he has to build up from here, right? What he do is he start from here, right? He try to build something new, attack here, right? Attack was successful, attack is up to here, right? If this is longer than this, he become the longest, that he can win, right? Because everyone will forget he paid something, right? This is how he attack, right? So the delta T will be the difference between the two. So I denote tau is the time that this would happen, right? The time happened. Okay? And this is the minimum time such that this is actually negative, which means that this is shorter than this one. It's a time that this is negative. Okay? So this is the time attack happened. Okay? Of course, there's random variable there because everything is Poisson, but this is the time that attack actually works out. Okay? Of course, if tau is infinity, the system is very safe. Right? If tau is very small, then you have to worry. Right? But tau is the number that the time that this is successful, right? Because it's a random process, right? This can happen or this can happen, depending on how this computing power attacker is fast, right? If this is very fast, this would of course happen a lot. Is that clear? Right? Because it depends on how fast this A can do and how fast this M and how big the Z is. Is that clear? Is that clear? This graph? Okay. So once we know this, okay, is double spending would occur if tau is finite, right? If tau infinite, there's no way to double spend. Okay? So this is a famous result which we don't prove when we have two Poisson process. Okay? If you try to look, this is called Gamber's ruin problem. Ruin problem. Okay. And I guess we don't need to go into the math, but I would like to highlight why this is true. Okay. First, okay. If attacker is faster than the miner, there must be some time that you would go broke, right? Because my grandpa is like, this is, you can imagine, right? If the two keep gambling, you go to Macau, casino, right? You lose more often than you win, then you will go broke for sure, right? If you win with probability 0.4, you lose 0.6, no matter how much money you start, you keep going, you go to zero, right? So that's the idea, right? If the attacker grow the block very fast, faster than the miner, you will always, in some time, they will catch up, right? You broke. And if the miner is faster than attacker, how likely that this would happen depends on relative power, right? If attacker is very small, it's a fraction, right? This will be smaller. Okay. and also depend on the Z, how long you wait. Okay, so that would be the model. Okay, you can. I don't want to explain the math because this math, even we teach undergrad, we don't give the result. This is just given. Okay, if you have two Poisson process, how much this is done in finite time is like this. Okay, the proof is a little bit complicated. Require you to learn some expectation, iterative expectation, so on and so forth, solving some difference equation to solve it. I don't want to go to that, but this is a well-known result. In probability, you can apply when there's a two process, okay, two Poisson process. When this more than this, okay, this is the solution. Okay. Now, with this result, okay, we don't explain. Okay, we can see the following. Okay. As long as, in theory, as long as we allow the merchant to wait long enough, okay, go to infinity, this will be 0, this will be 1, right? As long as we don't ask the merchant to send the good quickly, say wait enough time, this system is safe. As long as, it's A, sorry, typo, right? As long as the miner is more the attacker, right? And we know there are many miner than attacker, so that's why it's safe, right? And why there's enough miner? The reason is there's a block reward, right? If you add the block into the chain, you get some Bitcoin. They got miner, right? So there's so many miner there, right? So there's no worry about that, right? But of course, as you can see in this system, require a lot of miner, right? But at the end of the day, the block reward will go to 0, right? It requires some transaction fee, right? At the end, to transact Bitcoin, you need pay some money, right? But then, as long as this happens, it'll be safe. Okay? Okay, so that would be the model. Okay? And up to here, this is exactly the original paper, right? You may wonder why this paper would fly, right? Actually, this paper comes out and Bitcoin exists, okay? And you ask one thing is, very funny is, okay, this, if this Z is not infinity, right? This is still positive number, right? No one wait for infinity block to send the good, right? There's still some chance that attack will success, okay? So in theory, almost work, but there's sometimes doesn't work, right? If Z is not. But turn out this puzzle is like, although it doesn't work for sure, in a real world that no need to go to infinity, it still works, okay? Earlier attempt to create this kind of cache is not successful, right? Because of one of the reasons is they don't have the right way to decide the computational power, right? Because in order to add the block, right, you need to solve, right, require this, right? Creation of the block require computational power, right? Because the Bitcoin designed in the way that in order to create the block is proportional to the computational power, right? By making this is costly to add a block, you let the attacker not easy to attack. Okay, so this is how the Bitcoin is created. Okay, and the only thing I didn't go into detail is this probability theory result, which since we are not math class, I just give you here. Okay, of course you can easily check. This is a runes problem standard in the mathematical textbook there. Okay? And after the break, we'll talk about when you have this thing will happen. How to make sure this will happen, right? How to make sure miner have more power than the attacker. Okay, we'll give you some slide. Okay, let's a break of 15 minutes.
但係話我買嘅啦，我要產出呢個月，即係我買呢個月，咁我要擺呢個月，我要我 block 上㗎嘛，我 block 上原來你睇得上嘅好鬼貴㗎嘛，要 cost 嚟㗎嘛，係啊，我要俾翻你之後，我話我要產出，我要俾錢你，咁我要話我要呢個 price，如果邊個人試你呢個嘢，我就俾嗰邊講。你最邊個你要曬俾10個咁冇有啦，係好慢嘅辛苦啊，真係。我整咗個聲之後，我將我自己聲整走加其他人，我就加冇啦。嗰個咧叫咗我有幾錢有幾錢，咁我話我呢個 block 之後我俾幾錢你，我將呢個拎走咗，整個新嘅，除咗呢個即係呃鬼佢，即係你就我冇俾㗎，我冇屈我㗎，之後當你成日都係出面之後俾係啦。係啦，
呢個 model，如果望到
我又嚟
呢一個咧，呢個係條大口罩嚟，咁revenue 應該係 B 乘 Q 即係 P 乘 Q，咁 derive 個 marginal revenue 應該咁樣。咁其實如果望到佢嘅話，假設呢個係 M.Phil 咁佢係咪都有 incentive 去 reduce 個 profit？
係啊，我畫出嚟嗰時俾個數，因為我本來有咁嘅，我有計出嚟嘅。我呢個唔係就咁畫㗎，我 cost 就咁計出嚟。
所以其實呢一個 reduce 個
marginal profit。
所以其實佢都有 incentive 去 reduce 個 leverage 去
睇情況係嘛？
對於呢個真係0嘅時候咧，其實佢就因為 CA 除以 CM 嘅 1 嘅呢個最低嘅呢個係啊。之後咧，但係因為啲啲先 goes to zero，但係對於中間呢個嚟講嘅話，其實如果呢個係1嘅話，係需要好少先得。
係啊，過兩款都係 less than 1就可以。
less than 1就可以啦。
係啊，你0.9，你咧聽唔聽？
我理解。sorry， 我好彩。
唔係呢樣嘢，你搞錯就唔知㗎啦。
我就係搞錯。
咩？慢慢嚟嘅先。係啊，因為 Bitcoin 嘅話，如果唔教嘅話，唔好錢㗎。Bitcoin 落快咧，20%啊，幾高嘅。咁我哋講 Bitcoin 最新嘅 Bitcoin 講點樣？買咁呢個譬如譬如話 what is suppose spending what is Bitcoin when你記咗個課之後，取消咗，我做咗個新嘅清，即係話我係知我記張假紙叫俾你睇。 係啊，即係佢知係假㗎嘛，咁你以為嗰度實際上我唔係因佢都有非常多嘅。即係如果兩條飛嘅話咧，即係如果有兩條飛嘅話，最長嗰條就3分鐘。如果你點樣拉人，因為你一頭先係所有人都係機會上緊。呢度就係每個乜事都條傾人，每個乜事都講㗎，所以好鬼快嘅就電腦快，唔係話追大問題。咁啊，快啲玩完。係啊，點樣？咁啊，邊日搞嚟㗎？所以你要重新翻去報告，可能我哋需要你嗰啲 speaking 都係，所以一定要有結構會 process 嘅。你個 model 呢個嘢考緊，因為你要靠 proof of work 係太貴啦，所以而家譬如 interview 係 proof of stake，咁就唔係靠呢個嚟執行。啊，你講嗰題，但係呢個範圍咧，喺呢度你個 model 呢個你要做 build 出嚟，呢個 model 係你嘅。呢個 set up 咁後邊你個 B， 你個 B 係你個 number of minus。咁所以你要識得 B 先得，但係咁大 C 嗰陣時，所以一定要改另一個 system， 唔可以 base on 嗰隻 power， 你要 base on 其他嘅嘢，所以 even 因為呢啲最後會貴咯，貴到一個步驟可能會貴過一係就啲好貴咯，一係就啲一係就啲一係就係咁好多 feed 咁你要俾個成本啦，就唔可以做正常。唔係你可以飛啲大樓，大家好貴嘅得嘅，但係可以上升到日常生活就得。如果 Bitcoin 係實質咁我唔講複雜啲，但係咧，我話咧 Bitcoin 咧就應該我係 model 就 expect 即係唔會 work for small transaction， 即係我 expect。係啊，所以某程度大家要明白，我係因為佢唔係靠嗰啲 system， 唔係靠嗰啲 system， 係靠呢個 professional power 嚟解決嘅問題。即係話你有嗰個技術證明，即係你唔需要唔使 proportion 嚟做，唔係靠呢樣嘢。因為佢係靠你真係佢係靠 professional power 去做 double spending 嘛。咁最後尾嗰樣嘢要使錢㗎嘛，嗰啲錢先可以做到。咁最後尾咪係一路比較，即係要靠好多 power， 我知道老屈㗎嘛，老呃人㗎嘛。咁呢樣嘢咪最後尾只可以做到對大商場有細商場唔到。Bitcoin 你係想做好多細都想做到，咁所以你要用你嗰個 system 去做，唔係靠呢個 package。係啊係啊。有啊啲 short question，short question 係一啲唔使我會俾啲，即係我俾一個提示。唔係，即係會俾啲類似嘅問題。我係人工嘅，差唔多。因為你覺得我點都係唔分到嘅，可能係。但係我哋講唔講數學嘅人講數，因為嗰個係計數學，係講數學就咁但係佢呢邊係講數字個位喎，講數字點解解決到都解決到？係成功嘅人聽 double spending 成功，係啦，一刀身成功。
即係話如果你係咁樣，因為 hacker 係機嘅，咁你咪攞阻止佢咯。問數學嘅，咪緊張。但係數學係為咗我要去解釋呢嚿嘢。如果唔係你話我話係咁樣，就好似冇講過啦，係咪？So some of you ask me why we talk about Bitcoin, but I guess this is finance for econ practice, right? Econ for finance practice. So Bitcoin is one of the finance practice. So if I don't talk about Bitcoin, then it seems like I'm missing something, right? But of course, some of you worry about the exam or quiz or what, right? But as I said, this is not math class. I do not intend to ask for math derivation of symbol, right? But I would expect you to know, say, the logic behind, right? So suppose I ask, what is double spending? That you know, right? What is Bitcoin trying to solve? You know, right? When double spending would happen, when would the probability of double spending minimize? You should be able to answer those questions. Okay? I'm not expecting you to know, okay, this is the Poisson distribution, no. But they will just try to give you the idea why the argument works, right? Of course, since it's master level class, right? So that's why I need to give you the reason behind why I say those arguments. Okay, the math is just for the sake of argument. I intend to ask you what is the consequence, right? You can see this a lot of math here, but at the end, probably you need to know what is the conclusion, right? What into to understand what's going on. So what we said is before the break is if the computational power of the miner is more the attacker, the system is safe, right? But how to make sure this happens, right? Because this model don't have economics, right? So that's why you can't solve this problem. So now we have to put economics there, right? Probably answer the question, why talk about this, right? Economics is here, okay? When we will make sure that Bitcoin will work, and then we know why Bitcoin would fail. So now let's make some economics, okay? We consider the end user of the Bitcoin, okay? And he have two choices, either don't use the Bitcoin, maybe use cash, that gives you zero, normalize, okay? If you use Bitcoin, what's payoff? If they use Bitcoin, he will have surplus of V, the constant number. You can imagine that why just use the Bitcoin, allow him to hide his identity, or there are many reasons why he wants to use Bitcoin, but this is one of the reasons. Maybe he wants to buy things from overseas, then avoid exchange rate, so that is one of the reasons as well. And he if I want my transaction node to be processed, okay, I can say I don't want to pay any money, I want to pay CO free, F is 0 is fine. Okay? But if he want to make faster, he can propose a fee F. Right? It's a fraction of the Bitcoin price, right? Maybe F is 0.001% of the fee, right? So, and the fee is percentage of the Bitcoin, right? So that's why it's the cost if he propose F, okay? And he also have to suffer some cost of waiting, right? Because you need to rely on others to transact, right? It will be A is the how unhappy he need to wait, okay, for 1 minute, 1 second, okay, multiplied by A, and WF is how long he need to wait based on the fee, right? If he set the fee higher, this waiting time will be shorter. If he set the fee too low, then maybe very, very long, right? So that's why you would set some fee there to make it faster. Right? Just like you imagine selling a house, okay? If you give a high broker rate, then you will sell faster, right? Same thing, right? Because you need people to work, okay? So this is the model. Now consider miner. As we said already, each miner produce lambda, okay? It's homogeneous miner. Each miner has a computer, they produce lambda, okay? And in this model, we don't consider fork, okay? So everyone work on the same block. Okay? So that's why everyone, the M people there multiply will be the how the block build up, okay, at this speed, okay? Okay, it's a Poisson. Now we talk about economics. So we'll talk about how many miners will come in, depends on the cost and benefit, right? That will be the central problem because we want enough miner to be there in order to make sure the Bitcoin is safe, right? The crucial is the CM, okay? And how to determine how many miners there? Depending on two things, right? The cost of doing the mining business. The first is mining requires computer, and computer keep using it, they will die, right? The faster you use it, they will die. So there's some depreciation rate, delta times F, okay? Right? It's fixed cost. You can mean the fixed cost of mining. And mining, you know, is use a lot of power, right? Is the cost of electricity, okay, times, there's a typo here, this guy, okay, 1 over gamma, okay. Why 1 over gamma, okay? Because the block, the black block, create in a gamma way, okay? How long before one block act there is exponential, is 1 over gamma. So put it this way. So suppose the gamma is gamma, yeah, gamma, right? Is 2, okay? 2 per minute means what? There will be, say, make it easier. Why this case? Okay, consider the case. Gamma is 2, right? It's 1 minute. Okay, 2 per minute means that on average you will see 2 there, right? That means that for half the minute you see 1, right? Suppose in 1 minute you have 3, means that 1/3 of a minute you have 1, right? How long you wait until with 1 block is 1 over gamma. Okay? So on average, this is a time that someone will produce a block. Okay? So this is standard idea of Poisson, right? Because on average, there's suppose that two blocks per minute, right? So every time you need to win this game is only 30 seconds. Okay, you produce a block. Okay, because every 30 seconds there will be competition among every miner. Okay, is that clear? So let me repeat. Suppose the gamma is how fast the block being produced. Okay, say in every minute, right? If gamma is 2, means they will expect 2 blocks in 1 minute. That means that 30 seconds, half a minute, there's competition, right? You were the winner. You solve the game, then you're a winner, right? So that's why 1 over gamma. So this is a cost, right? Because you need to play the game, the depreciation, and this is the time that every time you would do it, okay? And what is the reward? Okay, the first one is every time you play, everyone the same, so 1 over m, right? Everyone is equally. The more people there, they're less likely to win, but on average, the symmetry is 1 over m, right? And if you win some Bitcoin, that the price of Bitcoin is important. And as we said, the reward of miner, there are 2 parts. One is the block reward S is decided since the inception of Bitcoin, right? I think it reduced half by every some block that it create. There's a rule that is exponential decay. Okay, it will eventually go to 0, but just like the block is there, and this is the sum of the fees. You create a block. There are many transactions there. You combine together, right? So you win. This is the winning. Okay. And because of free entry, okay, you expect that how many people get in, you just equate the cost to benefit, right? This equate to this guy, right? Then you end up in this equation, okay? This is the number of miner, right? And how many miners you have, right? At the end of the day, depend on several things. First is it depends on price. Okay? So what it means is Bitcoin is very expensive. That's why it's safe. If the Bitcoin is not expensive, it's not high price, it's not safe. So now it's safe. Okay? Because of the cost is very high. The price of Bitcoin is very high. Okay? And as we said, right, it's designed by a system, it will decay exponentially, right? Now it's good because S is high, right? But in the future, S keep decreasing, right? So if you want to keep good number of miner, the fee must go up, right? At the end, it will go down, right? So in order, if you want to keep the Bitcoin safe, right, collectively, it must be the case that the fee must be go up. Right? That imply one thing is Bitcoin, okay, if either it must be very expensive or it must have a lot of transaction fee. Right? And either way doesn't very good for e-commerce. Right? E-commerce, you want to say a lot of transaction goes on, right? If F is very expensive, then probably will not work. Right? But of course, if you are doing a big transaction, that would be fine, right? Small transaction doesn't work, right? So if the original vision that Bitcoin would do every e-commerce probably doesn't work according to this model, right? Of course, unless you say this depreciation goes down, maybe also okay, right? Computing power is very fast, maybe okay, right? Or in the old days, right? If E is cheap, right, also fine, right? Or the gamma related to how fast the computing speed also would work, right? So you can see security of the Bitcoin crucially depend on Bitcoin price, right? If no one trade Bitcoin, then it's not safe anymore. Okay. So eventually, it is possible that Bitcoin worth nothing, right? If worth something because people keep using it thinking P is going to be high, keeping the P high, then it will be there, right? It's a good equilibrium, it can sustain there. But if people think the Bitcoin is not going to worth nothing, like Warren Buffett, right, who said Bitcoin worth nothing, right? If you don't believe that thing happened, then this will be very low and Bitcoin will die. Okay? It's very similar to platform idea, right? Because I use it, you use it. Money is a platform idea, right? I use it because you use it, right? I believe the Bitcoin value, that's why I hold it, right? Everyone hold it, then it exists. If not, Bitcoin will die, right? So Warren Buffett, if you believe what he says, similar to this, right? Because Warren Buffett think the Bitcoin will be zero. Why? He used fundamental analysis, right? Value investing, right? He think Bitcoin cannot create resources, right? Using dividend discount model, right? Or P equal to expected MX, right? X is zero there, right? No payoff, right? So zero. If this is zero, Bitcoin will not be secure, and Bitcoin will die, right? And some of you ask, okay, if Bitcoin die, what else, right? And notice Bitcoin rely on computing power to secure the system, right? To fight off the attacker. And new cryptocurrency use other method to defend it, okay? In those newer systems, it works because it don't require a lot of money. But that's beyond the scope because even this, you complain. So we just stop here, okay? Okay. So I hope that gives you some idea. We actually give some prediction, right? Bitcoin will not really work out, right? It's like a bubble, right? At the end, right? So conclusion we have is, okay, we explore network externality, the platform, right? And tells you why network company burn money. And in this sense, we tell you the beta of those companies are high in the initial stage. Beta will be low when the market saturated. Okay, that's our prediction. Main thing is winner takes all, right? And second thing, we talk about Bitcoin. We explain the economics of Bitcoin, right? How Bitcoin can sustain itself because of computational power, right? But to sustain this computational power, either you must be Bitcoin is the price must be very high enough to sustain this M, right? So Bitcoin may be successful in terms of making cryptocurrency as long as people believe that the price can sustain at the right level, right? If people think that Bitcoin will be worth nothing in the future, Bitcoin will not be stable, right? It will die itself quickly, right? Because if no one is going to think it's worth, then there's no miner there. If no miner there, then people can fake the record, right? Everyone get attacked, then Bitcoin will cease to exist. Okay, so I think that explains the reason. Okay, and I think I'm consistent with what Warren Buffett said, right? If you use fundamental analysis, P equal to zero, Bitcoin will die. Okay, but how long people would conclude this will die, I don't know. Okay, of course, if people think Bitcoin is useful for doing big transaction, okay, then it might be okay, right? But if not, then there's an issue. Okay. So that's all for this one. Any question? Okay. And as I want to reiterate that we are not a math class. I'm not intend to ask a math challenge or math puzzle in our exam or quiz, right? And you need to know is the qualitative idea, right? What say from this equation you will be able to tell, okay, how the M is being determined, right? How many minor you have is proportional to this thing. You can, right? I'll ask you this kind of question, but math is not my my intention to ask. So for the remaining 10 minutes, I want to touch a little bit about macro, okay? But don't worry, there will be something very elementary. And I'm pretty sure that everyone would know it already, okay? But just make sure that we're on the same page here. So we'll talk about the basic thing, GDP, money inflation, classical growth model, ADAS model. So we'll talk about basic macro, okay? With the focus on the application rather than the model itself, because I'm sure that you guys are better than I do in terms of practice, I guess. So let's define what the macro is. Macro is simply studying the whole economy, right? The main variable interest will be output on price level, right? The GDP and inflation or CPI, right? Or we focus on the money market, interest rate and money supply, and look at the labor market, unemployment and wage levels. And these are the things that we look at. And because you guys are really good practitioners, so these are numbers, you know, that move the stock market, right? Any announcement of this will change the market quickly. And so in order to understand macro, very often we look at how the economic work is what we call the circular flow model. Probably I will just go to this diagram, right? And in this model, usually you will see the two agents there. One is household, and the other is firm. Right? Of course, you will say firm are owned by household, right? So why you distinguish them? But there are two economic functions that distinguish them, right? Because firm is going to produce, provide goods and service to people, right? And how they being produced is from the consumers. They provide labor, or capital, or land, right? And the blue one usually you call the real flow, right? The real flow. Real flow. Right? And of course, households are not work for free, right? They earn some income, wages, rental income, right? All this will be the income, right? And household is paying for their stuff. That's called expenditure, okay? And this graph actually later you will see, or everybody would know, I hope, is this the calculation of how large the flow is the GDP, right? The GDP can be calculated according to potentially all four can be calculated, right? If you're able to observe how much people will spend in total, right? That's exponential approach, right? You look at calculate the goods and service provided is also the approach you do, right? And the other way, look at all the income that people have, it's the income approach, right? And look at the labor, right? How much they get the money, right? Is also an approach, right? Potentially, okay? But of course, you can see some of them you can calculate, some of them you don't, okay? And look at textbook, usually they will tell you the how do you define GDP, right? It's the national income, right? It's like it's the market value of all the goods and service provided in a given period of time, okay? And this looks very simple, but there's some, probably many of you would know, there's a lot of difficulties here when the good is not sold, right? The inventory, right? That turned out to be, many of you would know, is the big source of variation of the GDP, right? The GDP actually fluctuates because of variation of inventory, right? But why? Because look at these definitions of market value or the final good and service, right? If the thing is produced but not sold, okay, it also counts as the market value of that, right? The value produced but not the value sold, right? Because look at the question, look at the circular flow of the chart here, right? As long as the good produced is not sold, it does not belong to the flow, right? The firm produced something. If not produced, it's not sold, in our current GDP still count, right? And turn out that if you look at the data, a lot of time, the inventory fluctuation is a lot of times the main source of fluctuation of GDP, right? Recession is because of the thing produced is not being sold, right? But that is the one of the thing here, right? The way we calculate, right, is a problem. As we said, we can look at 4 possible ways to look at it, right? And the most commonly people use is called the output approach, right? Go to the factory, look at all the goods they sold, and that's the GDP, right? Or another way, look at value add, right? Look at the supply chain, how many would be produced, right? But of course, as you said, this approach has a huge problem of inventory, right? If the good produced is not being sold, no one will buy it, then it's basically useless, right? Because no one will buy those things. It's not a good way to measure the income, right? So that's why this thing is there, but usually don't do this one, right? Usually what we do is this one, right? I guess. This is the one that we often see. It's called the expenditure approach, right? Is the GDPY is sum of 4 parts, right? One is consumption, right? People consume, right? I is the investment, and G is government expenditure, and NX is net export, right? I think everyone understands Chinese, right? Usually we call the 3 forces behind the Chinese economy is investment, and government, and export, right? And you ask, why know this, right? But now that's what the government trying to do, right? Is to increase domestic demand, right? 增加内需, right? It's exactly what they're doing, right? So you will see this actually, although this natural equation, this is actually how we analyze GDP, right? We look at, okay, which one is going to work or not, right? And probably you ask, okay, this equation is sufficient. Actually, you often see that's how people analyze the GDP growth, right? Look at future economy. What people do is look at this by part, right? The economists on the TV, they do this, right? Now let's answer this question. How is the economy in Hong Kong going to work? Okay, since you guys are expert, let's analyze one by one. Consumption. Is consumption in Hong Kong going to go up or go down? Okay, is it one thing you can see consumption go up more with more people, then will be going up? Is population growth up and go down? Is the society is aging, right? Consumption, right, is the problem. You can tell me, right? Okay. Investment, okay? Is Hong Kong having more investment? Okay? Is it people have more money to spend on Hong Kong business? Okay, or not? Okay? Note that investment means you actually buy something, okay? If the investment is like buying stock market, it's not going to be, it's not the investment you are talking about, right? Investment has to produce some new good, right? If you buy a house, it's not an investment because it just transfer money, right? Say if you have a house and I buy it, that is not investment, right? Because nothing is produced. You just exchange thing. Investment is like I buy a new machine, and the machine produce some good, right? Otherwise, not going to be there. G, government expenditure. Okay? How now Hong Kong as government, we have a budget deficit. Go. You can see whether G going to go down. I don't know. Okay? You can guess. Okay? The last one, net export. Okay? Net export means whether money goes out more than go in. Okay? And we know the cargo terminal has no cargo. And look at the border. Many people go to Shenzhen to spend their money, go to the Sam's Club, so on and so forth. So I don't know this. So GDP, you can guess. Okay? What's going on? Okay? Not so that's how you. If you want to say this is a useful framework, right? If you want to say the economy is going to be good, you have to give something. Give me some reason which part is going to be good. Okay? If you can't give me, I can't say it's going to be good, right? But maybe there's some way to do it. I don't know. I mean, I'm not a macroeconomist, so I don't know, right? I'm a microeconomist. Okay? Disclaimer, right? So if you are macro, then you know which one maybe they come up with a good way. But so far, I can't see it at the moment. Maybe I'm very short-sighted, but this analysis, right, would work. And if you don't like this, look at income approach as well, can tell you similar story, okay? The income approach will be why your income would be depend on the labor bill, right? How many labor and their wage, and capital times the rent, and firm's profit. Of course, there will be other factor like land or whatever, but in Hong Kong, I mean, land not putting anything anyway, so these are fine. So ask ourselves, do we expect our income to go up? Are more people get employed? Okay. I don't know this affect anyone, but I know probably you know, right? Recently, the Bank of America fired some people. I hope it doesn't affect you, but that happened, right? And capital, Hong Kong, we do have some capital here, right? A lot of money. I think we have for 3,000 billion Hong Kong dollar is parked in Hong Kong, right? And that create this, okay? But some money go to Singapore, we all know, right? So the capital go down quite a bit, right? And profit, and look at the profit of many companies in Hong Kong, the public company, look at the bottom line also shrinks. So look at this, doesn't seem to be very optimistic, okay? Maybe I'm too pessimistic, but I don't know. But maybe you guys are more optimistic, okay? And you can see how things go, but it's hard to be optimistic, too optimistic, okay? And you can use factor approach, okay? The factor approach will be same as income approach because look, you're measuring factor input as income, okay? So that is the free way to do, okay? No matter which way you do, same, right? Why you have to mention income approach, right? Remember when you look at the labor market unemployment rate, this unemployment will change the stock market. Why? Because that actually tells GDP as well, right? Look at why you look at the PPI, look at the how the firm do investment, these affect, right? Because all these things are closely related to GDP, right? And the stock market is reflecting GDP. That's come from the consumption cap M model, right? So that's why we study macro, not because macro affect the firm's profit, right? But of course, this macro will change our stochastic discount factor. Remember, your discount factor will be higher if GDP goes down, right? Because the beta times U prime CT plus 2, P plus 1, right? That is the thing, right? So that related to that, right? Because when you're poor, the future money worth more, right? Remember that, right? If you expect the future GDP goes down, right? You will think the future consumption is more, right? The future thing worth more, right? That's the important thing. You have to remember that part, right? And of course, you have to look at which company will have covariance with the GDP, so on and so forth, right? That's important as well, right? Remember the risk adjustment is the covariance of the return with the discount factor, right? So these things are related. So that's why we talk about macro. And to understand macro, you can see it's not very difficult, right? Even based on this decomposition, you see which part, then you can do it. Okay? Of course, because I'm a micro theorist, right? But for macro theorists, they'll give you a very complicated formula, maybe a lot of equation to get those. Okay? And what I know is the basic one. Okay? But that being said, research have shown the analysis done by me is better than those people. Okay? Not a joke, because they said, the prediction power of simple model in macro is better than the complicated model. Okay? So that's why I focus on simple model. Actually, the complicated model in the macro these days is a very complicated micro model. So they will have very complicated micro model, many equations to solve. But these days, we will be good to still using simple macro model. Okay? So I guess I end here. After next week, we'll talk about this one. Okay? And just one thing is our quiz 2 will be, don't cover the macro. So I'll cover up to the Bitcoin. Quiz 2 will be 17th of February.